All right, next stop, Mercury. Mercury is a planet that's closest to the sun. It is approximately a third of the way to the sun. It's actually more like zero point 0.4. The distance between the Earth and the sun, if the Earth to the sun is 1 astronomical unit, it's about zero point 0.4 astronomical units. It is smallest. It's the smallest planet in the solar system. Those of you still hanging on to Pluto, you might say, Pluto's smaller. Yeah, Pluto is smaller. It's part of the reason why it's not a planet. More on that later. But it's 4,880 kilometers across, so that's still bigger, more than twice as big as our moon. Close to it, and it's what, 2/3 the size of our planet in terms of radius. That makes it much smaller in terms of total overall volume, but it's still pretty good size. It's not a little tiny thing in there. It's extraordinarily dense. We sent a probe to take pictures. In fact, that's what this left-hand picture is a probe going around in circles taking pictures. Again, that gray spot on the right is a place where we just never got around to taking pictures. So we have a spot of Mercury at the time that we had no idea what was actually there. But in going around in circles, you realize it's quite a bit more massive than the Earth per volume. Not quite a bit. It's about 5.4. Remember, the Earth's about 4.6. Water's about 1. So it's sizably denser. Why is it denser? Well, it's right next to the sun. The sun is blasting one side of it full tilt all the time. And so as it's blasting the surface, it's ejecting things in the atmosphere. In fact, the atmosphere of Mercury is basically, some gases like oxygen and nitrogen. There's very little of it. It's thin. Like you would not see it as an atmosphere at all. You'd say there's no atmosphere at all. But it's also got things like sodium and potassium in this atmosphere, which are rocks on planet Earth. It's so hot, these things are getting vaporized. Aluminum would get vaporized as well. So a lot of the less dense solids that should be on the surface of Mercury are gone, are missing. And that's because the sun is basically baking it off of the surface. In fact, the side that's pointed towards the sun is usually it can get as high as 800 degrees Fahrenheit. Now, what's interesting is it has no atmosphere. We talked about this with the moon. What does it mean when you have no atmosphere? We have no atmosphere. You have nothing to hold the heat to the surface. The heat re-radiates out into space. So the backside of Mercury is negative 279 degrees. It's the closest planet to the sun. And yet, the backside is still negative 280 degrees Fahrenheit, almost. Same as the backside of the moon. Nothing to keep that heat in. It therefore re-radiates out into space. Also, Mercury doesn't turn very fast, which means it gives it plenty of time for the night side of the moon night side of Mercury to bleed off that additional temperature. How long it take the Mercury to go around? It's the second slowest moving planet. It is turning at about 28.6 days, is 1 day for it. Interesting enough, that's 2/3 of a year. So it's in some sort of strange cycle where every 3 years it resets both its year and its direction of the planet. So its years are basically its day is 2/3 of its year, and as it's going around the sun. All right. It is heavily cratered. Why is it heavily cratered? No atmosphere to protect it from rocks flying in. No atmosphere to erode in terms of rain and wind and those sorts of things to erode the surface. It does have some plate tectonics which disturb the surface, and apparently the heat and cold constantly causes it to grow and shrink. So Mercury's suffering from some sort of potholage. It gets bigger and smaller, and that causes it to erode some. But still, the surface of the Mercury, you see that picture on the right, that is a surface of Mercury, and it's got millions of craters, literally still on the surface. And so again, we've never been to the surface of Mercury. We've had no probes, as far as I know. It's supposed to have gone in 2018, but I'm 99% sure it never went. If it did, it'd take long. It'd probably be there by now. But so my guess is, though, they've never put anything on the surface of Mercury, and I will amend this later if I catch that. So we don't actually know the age of this planet, but the cratering suggests the same sort of cratering that happened on the moon, which means 3.5 to 4.2 billion years ago, there were a lot of rocks slamming into everything in sight on the moon, basically obliterating the surface of the moon. It probably was the same set of rocks, you figure. And we're in the neighborhood. We're pretty close to Mercury on a relative scale. So the odds are it's probably the same time frame it happened. We don't know that for certain. All right. All right. So no atmosphere, hot side, cold side, no atmosphere, craters because they cannot protect. There's no breaking up of craters as they come in. There's no atmosphere to protect it, and there is nothing to erode them once they're made. Those are the same craters that were there 4 billion years ago. Now, I have one other thing I'm going to show you. I'm going to show you a video. This is from NASA. What they've done is they've taken shots of Mercury, and they've taken the telescope, the Gödel telescope, and it's looking at the sun. Now, the Gödel telescope has some fascinating things. It can change the color of the background. Like it could show infrared heat and put different filters up. So what they're doing, it's kind of weird to the sun, is they're changing the different ways, because you can't look directly at the sun, right? So you've got some sort of filter up there always. And so they have different filters depending on what they're looking at. So what they did is when the Mercury was traveling in front of the sun, remember it's very close to the sun, they took pictures, they took pictures, rapid shot pictures. So you're going to see Mercury by jumping around a little bit. That's because the pictures aren't perfectly in sync, right? Like a movie picture, you would have a nice movie, you'd have a frame every 60 seconds. They don't have that. And in fact, they've gapped them. So this is a little bit longer. Remember, it takes it takes about 80 days for the Mercury to go around the sun. So because of that, what you're watching is approximately a month of its time. So you're looking at days, right? And they're going to do it in seconds. So you're seeing a series of pictures, but it's still fascinating. It'll give you a relative scale that's legit. These are actual pictures of Mercury taken from roughly Earth's neighborhood as it travels in front of the sun. So I'm going to cue that up here. You're going to see here in just a second. Here it comes. Play. Now here it is. Mercury traveling across the sun. And again, they're going to change the background. Different heat levels they're looking at. Some is radar imagery. There's a radar imagery of the sun. This is Mercury. This is the shadow Mercury. This is Mercury traveling in front of the sun. That gives you a relative scale right there. You can see some solar flares in the front. There's little Mercury traveling across. If you look really closely, you may have to squint. There's storms on the surface you're seeing, lightning arcs. Bigger than the planet Mercury itself is. Remember, Mercury's 2/3 our radius, so we wouldn't be that much bigger. So you can find Mercury. There it is. So the sun is immense. We'll get to how immense it is later. We are toys circling. And again, those are solar storms behind there. This bleed off here is the corona. It's just up being blasted off the surface. So that's what it. I'm going to get a brain here. Probably, who knows what's going to come next? So I'll quickly zip back over. So that is how big Mercury is. That's how big the sun is relative to each other. And I am done with this. There will be some questions following. Answer the questions if you choose to do so.